Hey, welcome, and thanks for joining me today. My name is Collins McGeorge. I'm with Industrial Magnetics, and today we're going to talk about magnets and their role in food safety, which is a very important topic, and I would suspect very important to you as you've taken time to join us today. The role of magnets in food safety has certainly increased in the recent years with the oncoming continuing regulations and programs that are implemented within your facilities to ensure that food is safe for the consumer, your customer. So without further ado, a little bit about myself. Again, Collins McGeorge with Industrial Magnetics. I've been with them since 2004, and I've been a regional manager since I started with them in 2004, responsible for essentially the Great Lakes and New England state region. And since 2016, I've also had the role of Director of Sales for the company. We want to talk about the role of magnetic separators in your facility, and really that breaks down into two different categories. Equipment protection, which simply put means process safety, and that means trying to prevent a failure of a piece of equipment that may have catastrophic effect. In other words, a spark that could create a dust explosion. That would probably be the most simple explanation of process safety. And then physical insurance, protecting a piece of equipment that has a high replacement cost or a high value to the productivity in your facility, such that downtime or damage to it creates a negative effect to your bottom line and your throughput and productivity of an ability to produce product. The second one would be product purification. This would probably be the more prevalent use of magnets and role of magnets in a food facility. Product purification means we want to check our raw material supply to make sure that the materials we're bringing into the facility to use in our processes are free and clear and clean of foreign material, including ferrous. Mid-process checks to ensure that we're not adding any foreign material, ferrous foreign material into the product or processes through either equipment or, unfortunately, employee sabotage does occur. So we want to make sure that those points are in place, those magnets are in place throughout the process to check that, as well as pre-packaging so that the yield is increased for your productivity and production ultimately at the end, maximizing your throughput. I think it's important that we cover some objectives here. We want to cover some terminology today. We're going to talk about circuits, materials, and separators. And then later on in the presentation, when Ken joins in here and begins to present to you, he will discuss industry requirements, testing, and documentation, which again has probably become more prevalent in your world over the most recent years here, and will, we suspect, continue to become important and more prevalent and more demanding, quite frankly. So some key terms or terminology here. Ceramic, that simply is a group of ferrites. They're compounds composed of iron oxide and one or more other metallic elements. So again, iron oxide and one or more other metallic elements. Most typical is strontium carbonate, and iron oxide. That would be your most basic. But the process of making ceramic magnet material is similar to the ceramics process for other type of ceramic material, and so there's a generic term. It's just generally accepted that ceramic magnet material is termed ceramic, but again, there's different types. Okay, same with rare earth. Rare earth sometimes is referred to as neo, but that's not really. While that is accurate, that's not all inclusive. There are different types of rare earth. Samarium cobalt neodymium iron boron. Those would be the two most popular. Samarium cobalt really is used because it has a higher temperature tolerance, but there are different grades of neodymium iron boron that have different temperature tolerance as well. So rare earth is, again, a generic term that covers a broad spectrum of compositions of materials. Most common would be neodymium would be terms you may have heard. Again, rare earth is the most predominant choice in food applications because of its ability to have extremely high strength and Gauss in your process to capture fine magnetic ferrous particles that you're ultimately trying to remove from the process. Gauss is simply a unit of flux density from the material. It's the amount of magnetic induction that a piece of material can have put off, or it's kind of the invisible energy, if you will, that the magnet material piece has. Gauss is measured with a Gauss meter. There are different types of tips within a Gauss meter kit, and they will give you different readings. And Gauss is a very reliable reading, but it is not easy to repeat. So the preferred method of testing a magnet, if it is oriented and placed properly and it's the right magnet for the job, for the application, the best method for validating and testing and auditing a magnet is pull test. And that simply is a measurement of the force, typically in pounds, required to separate a given known test size piece of ferrous metal from the magnet. Using a scale, could be digital, could be spring. And the pull test is done to give you the figure of holding force, again, typically in pounds. Buna N, Hydex, metal detectable, and X-ray components. These are all components within magnetic equipment that are used to clean the metal that has been collected from the magnet. And Buna, just so you understand what that is, that's a nitrile rubber, just in general terms. Hydex, that's a copyrighted name actually. It's a polybutylene terephthalate. It's similar to Delrin, but it is approved for direct food contact. Metal detectable and X-ray components, I don't think I need to really go into detail as to what those are, but however, they do make Buna and Hydex components that are metal detectable and X-ray inspectable, so that you can have those components in case they are a failure point, which they are the normal known wear item on most magnets used to clean the metal off, that you have metal detectable and X-ray inspectable options there. And then Neodox coating, and again, Neodox is a copyrighted name, but it is a USD and FDA compliant synergistically bonded material to help with product abrasion and product adherence to the magnet. So if your product's properties tend to be abrasive or want to stick to the processing equipment, Neodox coating is something that would be advantageous to consider. It doesn't chip, peel, flake, blister. It's, again, a synergistically bonded material. So it is one with the tube. As the tube were to, if the tube were to wear, the Neodox would wear just as the tube would wear. It would not chip, peel, flake, again, crack, blister, and whatnot. Moving on. Okay, so this slide here, I really would like to just talk about some general rules of thumb, using some of the terms that we just talked about so you understand what we're getting at there. Ceramic is typically used for equipment protection. The reason being, ceramic is good at capturing larger materials which may damage equipment, nuts, bolts, screws, larger wires, and the like. Ceramic is perfectly acceptable, and quite frankly, the cost of ceramic is less than rare earth. So when you're only looking for larger items, ceramic would be acceptable for equipment protection. When you're trying to do consumer protection, rare earth is generally the industry standard. It's able to capture fine magnetic dust, even as small as stuff that is edible, like enrichment in flour. It will not put that out of spec, but it does have the capability to capture and retain incredibly small particle size of ferrous material. Plate magnets, and we'll get to that in future slides. The plate magnet circuits are typically used for equipment protection. They're typically put in chutes, not vertically, and are used to help protect equipment. Radial or grate style magnet circuits, and again we'll get to that in future slides here, are typically used for consumer protection and product purification because you can implement radial or grate tube style circuits into and create situations where there is intimate magnet to product contact, where the material has to flow through, not just over like in a plate magnet, but through a series of tubes to continue on through the process. So what do we look at when we're in a situation? How do you evaluate where I put a magnet? What type of magnet do I put in the situation? We look at a lot of factors, and one of those factors is the product. What is it? What's the particle size? How abrasive is it? Does it stick? What's its moisture percentage? What's its angle of repose? How easily does it flow? Those types of things. How is it being fed? What's the equipment that's feeding the magnet? Is it metered? Is it coming off of a screw, out of a screw conveyor? Is it coming out of an airlock? Is it being pneumatically conveyed, either dilute phase or dense phase, pneumatically conveyed? Is it being vacuumed? Is it simply gravity fall out of a chute with no metering, where you're just flood feeding through a chute, columnizing, if I can use that term, the material up through the magnet? We need to understand all those things, and you should as well, to make sure that the magnet is doing its job but not creating a situation where the process is being bottlenecked or hindered because of the magnet, because it is an important piece of equipment. And also, what's the purpose of the magnet? Is it to purify or is it to protect equipment? And so we look at all those characteristics, and that really helps with magnetic product selection and, quite frankly, the cleaning styles and methods in which you would select a magnet. And you should use your resources, such as the folks here at Industrial Magnetics, to help you select that. They have folks in the field like myself that can come out and walk you through all these processes to make sure that you're relying on a magnet expert to help you implement the best magnet for the application or the issue that you're trying to resolve. So I mentioned a couple slides back magnetic circuitry and a plate magnet specifically. Plate magnets are pretty basic. In the image on the right, you can see that there's a dark gray line at the bottom below the north and south. That would indicate a steel plate. And then there are chunks of magnet material that are magnetized and loaded opposing each other. And then the red lines are the lines of flux. Those are really the working lines of the magnetism. They're lining up the dipoles in the flux density area to create an opportunity for the metal to adhere to the magnet face. And the strongest point is going to be the point closest where north and south are nearest. So the shortest arc in the center of that image is where you're going to see the metal begin to collect, and then it will kind of create these arcs in a pattern as the arcs get larger and more metal is collected. That is the pattern you would see metal start to collect on your magnet face if it was a plate magnet. Again, these are typically for equipment protection, nuts, bolts, larger contamination, as I alluded to earlier, and they're for metals with strong ferrous properties. Okay, oxidized metals, work-hardened stainless steels that are magnetic enough to be captured with rare earth are not something that you would want to put in a plate magnet in place to try to remove from your process. Okay, if you've got oxidation, rust, work-hardened stainless, you really do need to look at one, rare earth, but two, something different than a plate magnet in your process. Here would be a typical orientation of a plate magnet in your process on an angled chute. You would not want the chute to be vertical. Plate magnets do their work by reaching out into the product. In the image on the left here, the darker product, the black product, is the good going by, and the red is the contamination we're trying to capture. And so you can see here that it has to reach out into the burden depth of the product as it's flowing through the chute. And there's obviously velocity involved here, product speed. So you would want to put a plate magnet in an angled chute, and you can see in the actual product picture on the right what you're looking at. This would be a self-cleaning using air cylinders. The magnet is in the open position, so you would not be making product at this time. There would not be product going through the chute, but you would be looking at a situation here where the material again is flowing at an angle across the entire face of the magnet, and extracting the metal out of the process. The air cylinders are used to pull the magnet away from the chute and release the collected metal below into some sort of collection bin or tub that you would place there, either temporarily or permanently. I did want to bring this image into the presentation because it does use plate magnets in a vertical orientation, which I said is a no-no. There are better solutions if your product has very poor flowing characteristics. There are better solutions than using plate magnets on the sides of a vertical chute, like you see here pictured on the right, and again depicted with the blue being the good product, the blue dots being the good product, and the red stars being the ferrous that we're trying to collect. These magnets are just, when you put them in a vertical orientation like this, they are very prone to wash off or recontamination. As new product and new metals come in, they tend to want to wash off or help release the metals collected back into the processes. So we want to eliminate that and look at a different alternative than a vertically oriented plate magnet. So what do we do? What do we do when we have a vertical chute and we want to extract ferrous contamination? What do we do when we don't want to use a plate magnet because it's not a chute, because we're not protecting a piece of equipment? We're looking for consumer protection here. We build grate tubes, radial style circuits that have, as depicted on the right here with the red lines of flux and the gray vertical bars, those are the pole pieces, and we load a tube with magnetic slugs, cylindrical slugs, and we magnetize those and we force them in there north to south, so that the two souths and the two norths are trying to oppose each other inside the tube. And what that does is it makes the gray bars, also known as pole pieces, collect the metal. So they're very strong and very good at collecting metal. So we use this orientation to collect shavings, filings, and iron powders in your processes. And again, typically these are for consumer protection. Okay, it's a uniform field, 360 degrees around the tube, and can be built to pretty much any length that you would like in a repeated fashion. So that grate tube or radial style circuit is used in many pieces of equipment. This is the very basic piece of equipment. If you've got a product that you would want that flows very well in a gravity situation, you would use what's called a drawer and housing. So you can see here, this drawer and housing currently is in the open position. The magnetic tubes are pictured in the center, inside the gasket ring there that you see. There are 7 of them in this particular orientation. Those tubes are 1 inch in diameter. They're on 2-inch centers horizontally and vertically, and they are offset so that row 2 is centered between the opening of row 1. And this is done to create a cascading effect where product that flows well can cascade through and make intimate product contact with those tubes. Can be built with ceramic, can be built with rare earth, magnet material. Again, typically here you're going to go rare earth. You're trying for product purification at this point. This particular model is known as an easy clean model, where the operator is going to open up the magnet with the red-handled Destaco hook clamps there, and then manually pull the magnet drawer out on the guide rod bars so that the material is pulled through the housing. You can kind of see one white ring of a Buna seal there. It scrapes the tubes clean, and the material falls into the catch pan, which is in the bottom middle of the picture, kind of a rectangular gray shape there below the Buna seal and the wiper seal plate as pictured. So we also have other configurations of tubes. We make 3-inch diameter tubes. We've named those large tubes. The large tubes are used for product that does not flow as well as products that would be used on the prior slide or the prior piece of equipment in the drawer and housing. The larger tubes have larger reach out. They have higher holding value, but they do have less. They have more space between the pull pieces where the metal's collected. And again, the reason to go to a large tube housing is to create a situation where you need a magnet in the process, but the material just does not flow, or the lump size of the material is so large that you can just not fit it through, the 1-inch tubes on 2-inch centers like we were talking about in the drawer and housing. You can see here in the picture of the large tube, there are a couple of angled diverters. Those angled diverters on the top of the housing there that go along the same parallel to the tubes are centered over the tube, and they are actually in there to mimic product buildup. Because of the large diameter of the tube, we do not want product to build up on top of the tube, so we mimic that with the diverters centered over top of the tubes to help with flow. Again, this model here is an easy clean, same explanation as a drawer and housing. Guide rods, red-handled Destaco clamps hold the drawer closed. It's manually opened and then manually pulled through a set of wiper seals that are not pictured here. They're on the back side of that lighter colored plate that's along the middle of the tubes as it's pictured here. So again, even product that would be poorer flowing than what you could use on a drawer and housing or a large tube, we have what's called a roto drawer. And the roto drawer is, again, 1-inch tubes. They're on a cylindrical array on a common shaft, and that shaft is attached to a motor that rotates the tubes at a low RPM to help promote flow. Pictured here is a simple clean. So the drawer is manually opened, tilted vertically, and the tubes are wiped by hand into a collection tub or tray. This model is also available in self-cleaning, which would be the use of air cylinders to do the cleaning cycle. I should have said as well, the drawer and housing 2 slides ago, as well as the large tube, also have the ability to be made self-cleaning. Pneumatically, we take the large tube circuit, we put it in a pneumatic tube. It's called a bullet magnet. The tube, this is in the open position here. When it's closed up, the material flows out and around the nose cone. In this orientation, it would be a vertical upflow, and the material then, the metal sticks to the tube, and you can use this in a pneumatic application. Additional pneumatic line magnets would be the pneumatic line housing. Looks very similar to the drawer and housing that we looked at, but it's built to handle the pressure of a pneumatic line, and it forces that cascading effect through the magnetic tubes so that you have intimate magnet to product contact as you're blowing or vacuuming your product through the pneumatic system. So, analysis of the magnet location. Plate magnets are required where equipment protection is required. Great style magnets are after the last possible point in which contamination can be produced, again, right before pre-packaging. How accessible is the magnet for cleaning? That's going to kind of indicate whether or not you use manual clean, where you're hand wiping it off, easy clean, where you're using manually pulling open a drawer through a set of wiper seals, or air cylinders because you don't have access to it, or the cleaning frequency is such that it's just too labor intensive to dedicate someone to clean it as frequently as it needs cleaned. And then, is there a documented cleaning log available? Those are things that you should consider so that you know that the magnet has been cleaned on your regular schedule. So some food for thought here, and the pun there is definitely intended, but that's my dry sense of humor. So again, some important points we've talked about. Plate magnets are not for fines removal. They're for nuts and bolts. They're not for the small stuff. Plate magnets are too thin for adequate holding. So if you've got 4 inches of material going through a chute and the plate magnet only has 2 inches of reach out, you're leaving 2 inches of material unprotected. Thirdly, magnets are not cleaned frequently enough. You know, the magnet can only hold on to so much collected metal. And at some point, those flux lines, there is no more available magnetism to allow the magnet to capture anymore. So cleaning frequently is important. Magnets get modified in the field. If you're going to modify a magnet in the field, it was probably misengineered, and you should consider contacting that manufacturer and trying to get that corrected, or contact a different manufacturer and try to get that corrected, but consult someone in that case. Lastly here, oftentimes the value of self-cleaning is not realized until it's too costly to change or upgrade. And what I mean by that is these aren't just interchangeable machines. Changing from an easy clean to a manual clean, one where you open it manually and pull it through a set of wiper seals, they look very similar in design, but the other one with air cylinders on it, you can't just retrofit those in the field. So you're talking about a completely new repurchase at that point. And then, you know, not here on the slide, but things to consider: the value of magnetic separators in your facility and what they bring to the table. Increased plant efficiencies, reduced downtimes, less capital equipment repairs, streamlined preventative maintenance schedules. They hold your suppliers accountable to your standards. At this point, I'm going to turn it over to Ken Gentner. Ken is our compliance engineer. He's been with us for about a year, but he does have decades of experience regarding the topics that he's going to cover with you. I'm excited for Ken to have the opportunity, and Ken, the floor is yours.
Hello everybody, I'm Ken Gentner, and thank you for the introduction, Collins. I'm pleased to be here to present the next part of our discussion, covering industry requirements, testing, and documentation. As an agenda for this part of the discussion, I'll first touch on the overall food safety environment that we operate within and move into HACCP fundamentals, hazard analysis, and critical control points. I'll cover equipment certifications and the certifications that individual professionals can pursue to help advance food safety program efforts. And I'll wrap up with a discussion around plant surveys, audits, testing, and documentation. First of all, as just previously mentioned, hazard analysis and critical control points was a system developed by Pillsbury in the 1960s when the company was asked to provide food for astronauts in NASA's space program. Pillsbury adapted a failure analysis methodology from U.S. military as the foundation for HACCP, and it has grown since then into an internationally recognized risk management system. Now then, the Food Safety Modernization Act, managed by the FDA, was introduced and signed into law in 2011, essentially requires a focus on the prevention of food contamination as opposed to the reaction to that. And this also is a risk-based safety regime, which is similar to the risk management activity which HACCP is built around. Now then, I need to mention hazard analysis and risk-based preventative controls, HARPC, and this became introduced as a part of the Food Safety Modernization Act, and through this HARPC, HACCP has become a part of food manufacturers' compliance to the Food Safety Modernization Act. Now, HARPC is not a global standard, but it is a standard approach incorporated into FSMA for the U.S. market. And you should also view, I say that HARPC is an upgrade to HACCP, although it should be noted that risk-based approach is integral to HACCP. Now I'm going to cover some HACCP basics. HACCP is a process analysis methodology. It consists of 7 principles with 5 recommended prerequisite programs as the foundation. You can see in the chart that I've included the left-hand column is numbered principles 1 through 7, which are the HACCP principles, and the next column under description is the titles for each of those elements, the 5 prerequisite programs on top of the 7 principles. The right-hand part of that chart is where I've indicated Codex Alimentarius application guidelines and principles, and they're named virtually the same with a similar numbering scheme, although the application guidelines show 1 through 12. I'll get more into Codex in a moment. First, with regard to the Food Safety Modernization Act, HACCP does support FSMA. In fact, the FDA has provided guidance about how specific HACCP regulations are connected to the Food Safety Modernization Act. Now, with regard to Codex, HACCP isn't adopted by the Codex Alimentarius Commission. Codex itself is an international food standard. The Commission was established in 1963 by a joint UN and World Health Organization food standards program. The UN Food and Agriculture Organization, UNFAO, is partnered with the World Health Organization for a number of food standards activities, including Codex. Codex is very large. The member countries cover, it is said, 99% of the world's population, and that's in 187 member countries, plus the EU as a member organization. Codex has published standards for over 200 food products and associated with them 120 food guidelines. So you can see from the chart that Codex has directly adopted the prereqs and principles and has established published guidelines for their use. Now, in addition to Codex, HACCP is endorsed by the USDA's NAC-MCF, which is the National Advisory Committee on Biological Criteria for Foods, NAC-MCF, as well as by the Global Food Safety Initiative. Now, the GFSI is not a cert program. It's an industry-driven collaboration to advance food safety. If you can receive GFSI recognized certification, and that would be by one of the 4 organizations I've listed below that I'm going to go into. All right, the GFSI, by the way, was created by food industry leaders in year 2000. So GFSI recognizes, among others, these 4 major schemes which do require a traditional HACCP approach for a food safety program. I'll go through each one of those briefly. BRC, the British Retail Consortium, as its name suggests, is the leading trade body for UK retailers. The BRC standards integrate both Codex and HACCP principles. Their standards were first published in 1998. Safe Quality Foods, SQF, is a program run by the Safe Quality Foods Institute, SQFI, which in itself is a division of and administered by the Food Marketing Institute, FMI. Anyways, it was developed in 1994 in Australia by the Department of Agriculture there. It is, by the way, the only major food standard scheme that integrates a quality component in addition to food safety. FSSC 22000, Food Safety System Certification, is an ISO-based food safety management system, and if you read through the standards, it's structured very much like an ISO standard. It was first issued in 2009, or issued its first certification in 2009, and then just recently in January here, its version 4.1 of the standard is in alignment with the Food Safety Modernization Act and supports it as such. International Featured Standard. It was founded in 2003 under the name International Food Standard, changed its name but not the acronym shortly after that, and there are 10 key elements in the standard, and IFS calls them knockout requirements. If any one of those elements is not met, then you lose your certification. Call it a roadmap, call it a landscape, if you will. Across the top, I have, in org chart fashion, I have a number of leading regulatory agencies or industry agencies that provide guidance and standards and regs for regulations for food safety. So, under the U.S. Department, I'm going to start at the upper left. Under the U.S. Department of Health and Human Services, we have the FDA, of course, and the Code of Federal Regulations as a part of what they manage, and of course, Title 21 for food and drugs. I've got the Food Safety Modernization Act listed under here, and I've also included the alternate name, also known as Preventive Controls for Human Food Regulation. And that preventive controls is part of the HARPC, the preventive controls, the tail end of that. And I've got HARPC identified here also, as well as HACCP, because that's where standards and regs roll up to the FDA for food safety standards. I've also included in dotted line here, I've got HACCP International. They write standards for food safety, and I've got the International HACCP Alliance beneath that. Again, both dotted lines, but both based around HACCP. Very similar names, and I'll be touching on them briefly later in the discussion. Under USDA, I've outlined here the Agricultural Marketing Services, AMS. I have them listed here because they provide equipment review programs that, again, I'll cover a bit later in the presentation. I'll also point out that they have dairy processing equipment guidelines as well as meat and poultry guidelines, and the equipment review programs use those guidelines, as well as under NSF International, this NSF ANSI 14159, the USDA's AMS, Agricultural Marketing Services, also relies on that standard. And you can see here I've got NSF International because there's a lot of accreditations that NSF carries, kind of important. Back to USDA. The Food Safety and Inspection Service, all right, has within their jurisdiction the NACMF that I mentioned on the previous slide with endorsement for HACCP, and in addition to that, the U.S. Codex Office. USDA has a bit of equity, if you will, or pretty involved in Codex internationally, and I've got the dotted line from that down to this joint effort by the World Health Organization and the UN's FAO, which is Codex Alimentarius. And then over on the right-hand side, I've just briefly outlined or partially outlined what the Global Food Safety Initiative manages, and those four standard schemes that I went through are listed there as well. All right, primary certifications for food safety equipment. I'm moving away from the standards around food manufacturers or food handlers, and I want to discuss the certifications for food handling equipment. that are available through HACCP International and the USDA's Agricultural Marketing Services. Got a slide on each one of those. HACCP International, again based in Australia, they provide certifications for products, materials, and services that are brought into food processing and handling, which meet best practice in terms of food safety. They have published a standard, food safety certification standards, and that's what they build their certs around, of course. It provides validation for equipment's fitness for use within food processing and food handling applications. And they have a well-defined certification methodology. It's in a consistent assessment process where equipment is practically and scientifically assessed for all facets of food safety and their compatibility with HACCP food safety programs and overall contribution to food safety. They are recognized by JAS-ANZ, which is a conformity assessment body, which is also a member of the International Accreditation Forum. Anyways, JAS-ANZ is the Joint Accreditation System of Australia and New Zealand, and at the same time it's a global standard. Pretty demanding requirements and recognized globally. I have to take a moment and let you know that industrial magnetics equipment has received certification from HACCP International for our magnetic separation equipment, that is for separating ferrous materials from foodstuff, certified by HACCP International. And it's worth noting that HACCP International does promote and support companies whose equipment has been through a certification process. And here at IMI, we're proud to carry that endorsement from them. The USDA's Agricultural Marketing Service certification, also they offer 2 voluntary equipment review programs for the food processing industry. I briefly highlighted those on my organization chart diagram: the Dairy Equipment Review Program and the Meat and Poultry Equipment Review. And as I had mentioned, the equipment reviews utilize 2 relevant USDA guidelines plus the NSF standard, as I pointed out as well. Now the AMS equipment review specialists dive into engineering drawings and are pretty adept at reviewing actual processing equipment. And that's they're detailed and they know their standards very well. And the reason we know that is that they've been through industrial magnetics and they have undertaken reviews with us, and 6 equipment families, if you will, or product ranges have been deemed suitable to implement in food safety programs, and the formal acceptance by them is pending. We'll see them shortly on their published list of accepted equipment. Now with equipment also, component level certifications, we should be asked, we equipment providers, and are asked periodically to provide certifications for the components and materials that are part of our assemblies, part of our products, part of our systems that we put together. And so you can expect, if you are an equipment supplier, to be asked for these component certifications. And with that certification, what's typical is that we provide a cert that is on our supplier's letterhead and signed by a company official from our supplier. And it needs to cite the specific CFR part and subpart and include the trade name or other traceable part number, if you will, to get from the supplier cert into what they supply to us or back to the product that we put out the door. Regarding personal professional certifications, there are many certification programs out there and available from a number of accredited firms that demonstrate your qualifications in food and beverage safety programs in the industry. FSMA, the Food Safety Modernization Act, requires that every food manufacturer, food handler have on staff a Preventive Controls Qualified Individual, a PCQI, as well as other qualified individuals. Okay. Next bullet, safety managers, food safety managers. There's a few alternatives for certifications that support HACCP fundamentals and your ability to qualify as a food safety manager. The 3A organization has a certified conformance evaluator program. SQF has a practitioner that you can be qualified for. There are many auditing certs, including one by the Global Food Safety Initiative, and there's a number of others also. The list is exhaustive. Anyways, most of these are geared for food manufacturers and food processors. On this next slide, I want to speak to the logic and the rationale for equipment suppliers to go after some of these certifications. Okay, given the certification and the training and test activity that you go through to get the certifications, you demonstrate a working knowledge of government, industry, and audit requirements. All important. Consider 3 customers that we have. And the certifications also demonstrate qualification and additional capability for participating with other food safety professionals on HACCP teams and being effective HACCP team members. And as part of that activity with the teams, help develop HACCP plans that embrace good manufacturing practices or current good manufacturing practices, as well as overall the FSMA requirements. And also ability and confidence to perform third-party audits for equipment, and that would be at customer facilities, including verification and validation support. Validation becoming more and more important on top of the verification activity that we're all involved in. I'm going to take a moment and talk to you about the HACCP manager certifications that Industrial Magnetics has pursued for number of individuals at our firm. Our regional sales managers, as well as design engineers and our inside sales folks, have gone through this HACCP manager certification that was coordinated through the National Environmental Health Association, NEHA, and that certification is accredited by the International HACCP Alliance, so it's a global recognized standard. I briefly alluded to the ability to aid our customers with testing, evaluating, and documentation activity through plant audits. All right, and I'm going to cover some of the elements of those audits. For magnetic devices, magnet pull testing is by far the most prevalent or popular way to qualify a magnet out in the field. In addition to that, we stand back at the process and help analyze the application in regard to what task the magnet needs to perform, and above and beyond that, an analysis of the location and type of the magnet in the process. Collins described a bit of the selection process in his part of the discussion here. Preventive maintenance documentation is provided as part of this program, and recommendations for improvement, repair, or replace of the magnetic equipment. The pull testing, by the way, what's illustrated here is a typical kit, and of course there's a scale, and that can be a digital scale or a spring-loaded scale, various sized metal spheres to use as the test piece or test instrument between the magnetic and the magnet and the gauge, a round test plate which is an alternate to the spheres, polarity tester to see where north and south is, and air gap spacers in the kit if you want to evaluate the strength at some distance away from the magnet surface itself. When we go through the process of evaluating magnets in the field, we have 4 ratings. Of course, good means that the magnetic equipment, the cleaning is operating well, the seals are good, the magnet surfaces are still in fine shape. Good as new, as effective, no changes or updates required. We have a caution rating, yellow, where tubes or seals are beginning to show some wear or some sign of degradation. And they interpret that as go back regularly and take another look and replace worn parts as needed. 2 more significant findings. A warning is that you can see in the picture, visible signs of wear, and that's from the material, especially the tramp metal, wearing on the tubes, in this case tubes, as the material travels by in the application. And the warning is to replace the worn tubes as soon as you can. And danger means get the parts out immediately, and that means that the casing or outer surface of the magnetic tubes in this case may be completely worn through, such that you seal magnets or damaged seals will cause the unit to fail completely. The magnet audit activity is wrapped into and part of an overall preventive maintenance program that we offer, which is assistance for preventive maintenance, service, regulatory assessments, audits, and related requirements. And the benefits of engaging a firm like Industrial Magnetics for programs like that: you receive independent third-party auditing and documentation that keeps you in compliance with regulatory requirements. We perform a visual inspection, checking for excessive wear, replace worn parts, cycling through the mechanicals, etc., to make sure they're in good working order, not just a static visual inspection. We'll perform and document magnetic pull tests and provide recommendations, watch lists, recommended replacement parts, etc. Now then, if you engage in an audit program with us, a PM program with us, if that results in a qualifying purchase from Industrial Magnetics, you receive your own free pull test kit, handy, and that can be used on a regular basis instead of just a periodic audit that you may schedule. So then, just as a little bit of a wrap up before Q&A, why use Industrial Magnetics? We pride ourselves in the USA made products, and that's an acronym for manufactured, assembled, designed, and engineered here in the States. We have factory, regional, and local support across North America. Customized and computer designed circuits, and when I say circuits, I'm referring to a physical magnet and pole piece layout, various design circuits for optimal magnet performance, over 50 years of material handling industry experience, and open door policy as always with our customers, and the preventive maintenance and service program for in-field support. Now, I think we'll turn it over to our facilitator to receive questions.
Okay, gentlemen, thanks so much for that great presentation. Now, we do have some questions that have come in from the attendees. So before we get to those, let's remind everyone that if we don't get to your question, don't worry. We'll have an answer for you following the webinar. The complete Q&A transcript, including answers we don't have time for, will be sent to all of our registered attendees and will be posted with the webinar when it goes into the on-demand mode. Okay, Collins and Ken, I grouped the questions as they came in for each individual. So I'm going to start with questions for Collins, if that's okay. So Collins, your first question is, generally, where would I look to put a magnet in my facility that uses wet and dry ingredients for food production?
Well, first I would look at receiving. I would like to know that the products I'm bringing in are clean of ferrous contamination. And so when I say receiving, I mean bulk receiving, truck, rail car, super sack, as all the way down to 50-pound bags or any other micro ingredients you may be getting in smaller quantities. There are magnets that can be put in place to handle anything from little hand-add dump stations all the way up to rail car and bulk truck receiving lines. You want to put magnets before your processing equipment that could fail if metal is present, like I mentioned, hammer mills and screeners. Screeners get broken, screen wires become contamination. So maybe it's important to have a magnet either before your screener or after your screener, or both. You want to put them throughout the process to eliminate internal equipment contamination. Again, at manual add, bag dump stations, screw conveyors, airlocks, silo discharges, these are all common places to put magnets. And then before packaging, it's that last point to check before your product is out of your control. This may be before wets and dries are combined in the case of a baked good like a pretzel or a dough that's being made or a bun that's being produced. Once you combine your wet and dry ingredients, it's hard to capture small ferrous contamination. So maybe the magnet needs to go right before the mixer. But that's a good question.
Okay, great. Thanks, Collins, for that answer. Here's another question for you. With regard to how the magnet is cleaned, how would I know which cleaning style is best for my application?
Well, you want to look at the frequency with which you need to clean. The more often you would need to clean, I would tend to tell you that self-cleaning, use of air cylinders controlled by a PLC and so forth, would be the most beneficial to you and the least labor intensive. Also, the amount of metal you have in the process. If your metal content or contamination is higher, you're going to be cleaning your magnet more frequently, and the amount of metal makes magnets more difficult to clean because magnets want to hold on to the metal, so it makes the friction increase and therefore more difficult to clean. So if you have a higher amount of metal, you'd be cleaning more frequently to make the process of cleaning easier. The accessibility to the magnet, if the magnet's up at the top of a silo, up in the ceiling, in a location that's hard to get to, under a piece of equipment, on the opposite side of a wall, a long walk from the operator that's really in control of that process. And then also the criticality of having the magnet cleaned on time, every time, and correctly. So just because you have a magnet there and you have someone that says they are going to clean it and they mark a log that says they did clean it, that doesn't necessarily mean that it got cleaned, or if they did try to clean it, maybe it was too difficult to clean and they only cleaned half of it. So in those situations, the value of self-cleaning really is something to seriously consider. Those are basically between manual clean, what we call easy clean, and simple clean are the three methods you can consider. But cleaning frequency, amount of metal, accessibility, and criticality of the magnet are really what would dictate what kind of cleaning style you should select. I always start at self-cleaning and then go backward from there.
And Collins, thanks again for that answer. Here's another question. Do we still need magnets if we have metal detectors and/or X-ray equipment? And if so, why?
Absolutely. Metal detectors and X-ray equipment are actually complementary to magnets and vice versa. They increase your yield. If we can extract the ferrous contamination before a metal detector or X-ray equipment would reject your final product, then you've increased your output. You've increased your production. So oftentimes magnets are used in conjunction with metal detectors and X-ray equipment. They're placed just prior to the metal detector or the X-ray equipment to extract that ferrous metal before a rejection would occur. Secondly, with regard to metal detectors and ferrous, magnets can actually extract smaller particle sizes than metal detectors can detect. Most metal detectors in most products are going to be good for about 0.8 to 1.0 millimeter size ferrous contamination. And as I mentioned earlier in the presentation, rare earth tube style magnets can actually extract metallic dust size particles. And then magnets can be used in a HACCP program as a CP or a CCP. So just like metal detectors and X-ray equipment, they too can be used for control points or critical control points in your food safety program?
Okay, Collins, thanks for those answers. Now, this next group of questions came in for Ken, so Ken, these are for you. We don't have a formal food safety program in place. How would you recommend we get started?
Well, I would suggest following the 7 HACCP principles as a great way to get started, complete with a look at the 5 prerequisite programs. If you recall the chart, it begins with a bit of a definition of the product and its intended use, and this would refine scope or define scope for the rest of the effort. And I really want to point to the flow charting as a part of the prerequisite program. That's very, very important. And in the flow chart, we want to make sure that we include every ancillary process that maybe you're adding water to the system, or there's air makeup or other tangent processes as a part of that. A flow chart with every process step identified and numbered would be a great way to structure this, because any of the subsequent activities in the HACCP plan could be numbered accordingly and traced right back to the flow chart. And in that way also, for the regular periodic audits, you can have the roadmap to go through and take a look at each process element and see where there's critical control points or other control points that are not deemed critical. A great roadmap to get started and follow through all of the 7 HACCP principles would be the way that I'd address that.
Okay, Ken, thanks for that answer. Here's another question for you. Is it necessary to have a third party perform audits on equipment or processes, or can we do them in-house?
To answer that question, I have to say, first of all, that the third party is not required. Verification and validation activity can be performed in-house. The benefits of the third party is the independent objectivity, as well as if you don't have built-in systems for how to document the findings of a third-party activity, then that can be provided by the third party with the standard forms. Your forms or your format for reports would be preferred. At the same time, yes, most independent third parties that would perform the audits can provide that service also with the format of the documentation. And speaking of documentation, the documentation really is key. Recall that that's the last step in the HACCP principles, is record keeping, and that really is the evidence to compliance to regulation, is the documentation. You know, the audit line is if it's not documented, it never happens. So the documentation is key. So with or without third party, I'll focus on the documentation right in there as a part of the HACCP principles is really the end game there.
And thanks again, Ken, for that answer. Here's another question for you. How often do we need to go through the audit process to stay compliant?
Answer that question at least annually to support HACCP reassessments. That's part of a Code of Federal Regulations, annual reassessments, and annually is a minimum triggered by the calendar, and there's also other reasons to go through the recertification and effectively an audit process. For instance, if you introduce a new product, or there's a different makeup to the product, or if you introduce new processes, or if new supplier is on board, other reasons go through this at least annually, however, as required by the regulation. Now, with a viewpoint on continual improvement, I'd be inclined to do that more often so that trends can be identified and monitored to see if there's additional actions, and again, continual improvement actions either for efficiency or for better safe food program. With regard to the increased frequency, though, one thing to be careful of is that if you specify or if you include in your procedures that you will do monthly audits or assessments or quarterly or semi-annually, you have to make sure you do them. Like any standard, you have to state what you do and do what you state. So you have to make sure you do those once you put it in the procedure documentation that you're going to, annually at a minimum. Thank you for the time today and the attention that you gave Collins and myself. And further questions that we did not get to or that may trickle in later, we're happy to entertain those and get answers back to you by ourselves or by other reps from our firm. Our phone numbers and emails indicated here. Thank you.